Hello and welcome to Neon EVM Bootcamp. During a series of 10 videos, we are going to learn how to deploy smart contracts using Neon EVM, thus bridging Ethereum tooling with Solana's network. Throughout the entire bootcamp, we'll be using Solidity and all the familiar Ethereum tooling. And using these tools, we'll show how Neon EVM's libraries and composability feature allow to launch any Ethereum dApp on Solana. We'll be sharing all the educational materials and supporting you on Discord throughout the entire journey. Today we are going to concentrate on ERC-20-for-SPL token. We'll deploy it on Neon EVM and test it on Solana. So the structure of the tutorial is pretty straightforward. We'll look what Neon EVM is and why it is used. Then we'll go into the details about the ERC-20-for-SPL token. We'll see how it's different from an ERC-20 token and how to work with this token on Solana. And then we'll go into the code. We'll set up your environment to work with any Neon EVM project and deploy the smart contracts to create a mintable ERC-20-for-SPL token on Neon EVM factory contract. And then we'll send a transfer composability request to Solana and see how it goes. So what is Neon EVM? Neon EVM is a Solana's network extension created for the integration of EVM dApps. In other words, it is a fully Ethereum-compatible environment built on the Solana blockchain. This means that you can deploy Solidity smart contracts on Solana without rewriting them in Rust. Neon EVM enables Solidity and Viper-based dApps to tap into Solana's network benefits, and you know all those benefits: low fees, high transaction speeds, and parallel execution capabilities. So from a developer's perspective, this means creating Solana-compatible contracts using tools you're familiar with from the Ethereum ecosystem. Neon EVM resolves the main hurdles in Ethereum-Solana interoperability, which arise from the differences in their architectures and standards. For example, when Ethereum saves account balances in a mapping in the contract storage, Solana creates separate accounts and doesn't store balances in the state of the contract. Specifically for this issue and others, Neon EVM created a composability feature and custom libraries that translate the logic from EVM to Solana without the need to rewrite the contracts. Composability means that your smart contract can seamlessly interact with any existing program on Solana. It acts sort of like a gateway to the entire Solana ecosystem, whether it's a native program like System Program, SPL token, or staking program, or a custom program built by other developers such as a DEX, lending protocol, or a vault. For example, one of the simplest use cases would be performing a token swap through a DEX on Solana, or depositing tokens into a vault, all directly from your smart contract without needing custom integrations for each use case. And to do all this, composability uses precompiled contracts. They handle Solana instruction data, which is different from Ethereum's instructions. You can find out more about Neon's precompiles here in the docs. And this precompile here, I call Solana. We are going to use this precompile in this tutorial because it handles the transfers. It accepts Solana's instructions, routes it through Neon's Solana-based runtime, and basically handles instruction execution, account discovery, atomicity enforcement, SOL token provisioning via payer accounts, and other things that we are going to show you later. So have a look at other precompiles as well when creating your own composability use cases, because they are going to help you translate Solidity logic into logic that Solana understands. Now let's talk about our main topic, which is an ERC-20-for-SPL token. This is a hybrid token unique to Neon EVM. You know that normally Ethereum and Solana have separate token standards, ERC-20 for Ethereum and SPL on Solana. Now, Neon EVM's SPL interface allows native Solana tokens, SPL, to be accessed through the ERC-20 standard interface. In other words, it wraps an SPL token with an ERC-20 smart contract so Ethereum tools can treat it like an ERC-20. And a Solana user can use his Solana wallet to interact with EVM-based application deployed on Neon, use their tokens within this application, and do transfers and anything they want with an ERC-20-for-SPL behind the scenes. Okay, now let's set up the environment to work with any Neon EVM project. We are going to be working on the testnet, which is a Neon DevNet. We'll configure our MetaMask. You can find the credentials here in the presentation, but also in the documentation for RPC, URL, chain ID, currency symbol, everything else. Then we are going to go and get some DevNet Neon tokens to pay for gas when we make transactions and deploy the token. So these we are going to get from Neon Faucet. You can request 100 in a couple of minutes, I guess, but yeah, make sure to request about 250. I guess this is how many you're going to need. Then we'll also request some test tokens from Solana. We'll be adding our Solana address as well. Now, for the project setup, please install obviously Node.js if you don't have it yet, and Hardhat. Then make sure to add the dependencies and Web3.js, SPL token, BS58.env obviously would be among them. Now, for the Hardhat config for Neon, make sure to specify the RPC URL and chain ID in your Hardhat config.js file. And as for the env file, this is where you need to add your private keys for the MetaMask wallet and the Solana wallet. And for this key in the middle, you can just generate a random 32-byte key. Now let's go and have a look at one of the differences between ERC-20 and our ERC-20-for-SPL tokens. For example, ERC-20 has a mapping of balances. Each user, each balance is being stored in a mapping which uses storage slots in the state of the contract. Now, Neon EVM's ERC-20-for-SPL doesn't have balances. This means that balances are not recorded in the state of the contract. The official ERC-20 has a method called balanceOf, which is reading the balance state, and the function is saying here, for example, give me the balance of the user from the state. Now, ERC-20-for-SPL, the situation looks different. We don't store the balances inside the mapping in the state of the contract, but they are actually existing in Solana in separate Solana accounts. The contract creates a new account every time it's needed. For example, you use a transfer method to a new account that has never been seen on our chain, and then we'll run a check if it's a system account. In case it's a new one, we'll initialize a new account, and when this account has been created, it can be requested with the balanceOf. So balances are stored in separate accounts in Solana, not in the state of the contract when using ERC-20-for-SPL. Alright, now let's go and create our deployment script. Keep in mind that this deployment script we are creating not only to deploy this token, but also to deploy this other contract that has the composability logic, which we'll come to a bit later. So first we'll concentrate on the deployment script, and then we'll go to deploying the contract that has a composability request that handles the transfer, that creates an associate token account for the contract and a random receiver, and creates approval for the tokens, and also actually performs the transfer. Let's start by importing everything we are going to need. We'll need obviously Hardhat and Web3.js. Then we'll need to decode a Solana private key in base 58 and use Solana's token utilities for getting the ATA, associated token address, and creating the ATA instruction. Then obviously we'll need to load the config file, which contains connection details like the Solana node. And okay, now let's go to create a connection to Solana RPC node with Web3. Then use the Solana key pair with a private key that we are going to enter into the env file. Please keep in mind that Neon EVM DevNet is public, so use a special private key for testing purposes only. And now we only have a couple of steps left, so we are going to load our factory because we are deploying through the factory, and we'll attach an already deployed factory address, DevNet ERC-20-for-SPL factory on Neon EVM. So now we can proceed to deploying our ERC-20-for-SPL contract. Now the parameters you need to specify here are mainly the name, the token symbol, 9 decimals, and the owner address, the sender. Now these here you can see Dev Bootcamp token, DBT, 9 decimals, and user 1 address. So you can do something similar. And next, in this deployment script, what we are going to do is deploy another contract which contains our composability logic and creates associate token account for the contract and for the random receiver, approves the tokens, and then actually processes our transfer. But now to go further with this deployment script, let's go back to the composability feature and to the contract where we create all this transfer logic using the EVM precompiles. Let's have a look at this contract that uses this precompile I call Solana to create a composability request to transfer tokens to Solana. Now, previously we talked about how balances are stored in separate accounts in Solana versus how they're stored in contract storage on Ethereum. And each of these accounts on Solana has only one owner, Neon EVM program, which is a program on Solana. Only this program has permission to make state changes. So when we perform composability requests here, for example, Solana will see that this contract doesn't have permission to make changes to these accounts. So on Solidity level, everything outside the composability feature, it's actually the Neon EVM program who is making the changes. But when you perform a composability request, it's only the contract is the caller of the instructions. Outside the composability, it's the Neon EVM program. So here, transfer the tokens from the user to the contract's arbitrary token account, who is the owner, who is the Neon EVM program. I have access to the tokens only on Solidity level. I don't have access to these tokens on the contexts, in the context of Solana. So it's a transfer of the tokens from users PDA to contracts PDA, and for both of these PDA accounts, the owner is the Neon EVM program. This is why at this step I still cannot make changes to the tokens in the context of composability. But I can say that I want to transfer this amount to sender ATA and move these tokens to the account owned by the contract itself, and now I can proceed with the instruction, which will transfer the token from the contract's arbitrary token account to the contract's ATA account. So now sender ATA is the owner here, the contract account is the owner here. And then we prepare specific instructions for Solana. So this here is a skeleton of instructions where you need to define accounts and for each account identify a signer. And then you also have instruction data. And so the second method is to format the Solana instruction data. In Solidity, we have something called encoding and decoding through ABI definition of the contract. And in Solana, it's called serialization, unserialization. So this is basically a serialization of instruction data in a way that Solana architecture is expecting it. So this is where we build this instruction data, and then we format this here, and then we pass the formatted instruction to Solana in a precompile we discussed before, I call Solana, and this precompile is defined very early in this contract, yeah, right here. So yeah, this is again a custom precompile by Neon EVM. It has a different set of methods to support the interaction between EVM and Solana. And now that we know what happens in the contract that has the precompile and the transfer logic, let's briefly go back to the deployment script and see what else it has in there. So what we have here is the deployment of this contract that has the transfer logic. We are going to convert the contract address to a Solana compatible public key. Then we are going to generate a random Solana wallet and create ATAs, and then create ATA accounts on Solana, approve token transfer from the EVM contract, and initiate the transfer via our composability call in the contract that we just saw. So this is it, and now that we know what happens here, we can proceed to actually running this deployment script, and let's see what happens there. The script is running, and what happens in the script is we deploy the contract for ERC-20-for-SPL mintable token. Then we deploy the composability request contract, test Dev Bootcamp contract, and then we create the associate token account for the contract and for the random receiver, and then we have one approval. So yeah, basically to deposit tokens to a smart contract, you first have to grant approval for the tokens. And then, so the last step is to actually process the transfer. All right, now let's go to Blocksketch and have a look if our contract is deployed. Okay, so congratulations. This means that the contract is deployed. And then if we go to Solana, we are going to see that our transfers are actually there as well. So congrats on completing these steps. Now the next things you can do, well, actually three things. You can either deploy the contract only, which would be a beginner's task, deploy an ERC-20-for-SPL mintable contract, or you can do an intermediate task, which would be to create the same composability request using the instructions that I've shown you. And a more advanced task would be to create your own composability contract and create your own use case for a new composability request and see how your token performs on Solana. Thank you very much for your time. See you next time.